Hey everybody, Mr. Beckstrom here, and today I want to do an example. This is in section 6.2, and it says the point given below is on the terminal side of an angle theta in standard position. Find the exact value of each of the 6 trigonometric functions of theta. And they give us the point 6, -7. So with these kind of problems, I like to first kind of graph that point, make a triangle out of it, find the kind of the missing side length, and then go ahead. And then all of our 6 trigonometric functions come really easily. The only real tricky part, not even really tricky part, is just to remember which of those are positive and which of those are negative. I find that when I put this on a quiz or a test, that that's usually the part that most of the students will get points taken off from. Alright, so I'm going to make just kind of a crude, not that crude, but kind of a crude graph here. So I'm going to go about 6 in the positive x direction, a little bit farther in the negative y direction. So I've got a point down here, and I'm going to kind of draw a line going down to that point. So I'm going to make as straight as I can without using that calculator. That's good enough. Alright, so I have a triangle here. So this length here is going to be 6, because this point here is 6, -7. So 6, -7. Alright. Because this is our angle here in standard position. So we just kind of make a triangle. This is going down -7. So this length here is just 7. I'm just going to put that length there. And then this length here is the one that I got to figure out. Luckily, this is a right triangle, so this is just the hypotenuse, so we could figure that out by using the Pythagorean theorem. So 6 squared is 36, plus 7 squared is 49. So 36 plus 49 is 85, and I don't believe 85 has any perfect squares in it. So I can just leave the length of this side as the square root of 85. So now that I have that, here is the angle theta. That's going to be the central angle here. So this is the one that we're going to use. We are not going to use this other one here. We're going to use the one that originates from our origin here. That means that this 7 over here will be our opposite side. This 6 over here is going to be our adjacent side. And of course, this root 85 is going to be our hypotenuse. So before I even get started, I'm going to go ahead and mark which of my angles are going to be positive and which one of those are going to be negative, just to make this a little bit easier. So let's just go ahead and write all of them down. So we're going to have the sine of theta is equal to cosine of theta equal to the tangent of theta equal to, we'll go cosecant of theta equal to the secant of theta is equal to, and the cotangent of theta is equal to. And there are some tricks to figure out in which of these quadrants they're positive and negative. There's the word C-A-S-T, cast. It's C-A-S-T, but I always remember everything's positive here, right? Your x values are negative here, where your y values are positive. Here, both your x and your y's are negative, but your tangent and cotangent are positive because x divided by y is positive. And here, your y is negative and your x is positive, which makes your tangent cotangent negative. All right, so what are we going to do here? So we want to know. So here, sine is going to be negative. Cosine is going to be positive. Actually, I'll probably just leave that alone. I'll need to put a positive there. Tangent will definitely be negative, right? Because it's going to be negative divided by a positive, so negative. Cosecant is going to be the same as sine, because this is 1 over sine, so that's a negative. Secant, that's just 1 over cosine, so that'll be a positive. And cotangent will be a negative. So we'll have 4 negatives and 2 positives. So go ahead and get those signs out of the way so that we don't have to even worry about those. Now, we can just go through. I'm going to go ahead and write my SOHCAHTOA down. That way, less chance of making a dumb error there, right? So, SOHCAHTOA. And just go through them. All right, so it's all 6 trigonometric functions. So the sine, starting with that, that's opposite over hypotenuse. So 7 over root 85. So that's just going to be, oh, gotta go back to my pen here. So 7 over root 85. And I know usually we will rationalize the denominator. I did check with my math lab and it did take it just like that, so that was fine. If you do need to rationalize the denominator, then you just multiply the top and the bottom by the root 85 and you'll get 7 root 85 divided by 85. And I do not believe that 7 goes into 85. 85 divided by 7. It does not yet. All right, and the second one here, cosine. That's adjacent over hypotenuse. So that'd be 6 over root 85. That's 6 over root 85. That'll be positive. All right, tangent is opposite over adjacent, so negative 7 over 6. Don't want that one. The cosecant is, so if the cosecant is 1 over sine, sine is opposite over hypotenuse, then the cosecant is hypotenuse over opposite, hypotenuse over opposite. So root 85 over 7. So it's going to be negative root 85 divided by 7. The secant is going to be just the reciprocal of the cosine, so that'll be root 85 over 6. It's going to be hypotenuse over adjacent, so hypotenuse over adjacent, root 85 over 6. And then the last one is the cotangent, which is just going to be adjacent over opposite. So it's going to be 6 over 7, or just the reciprocal of the tangent. And it's going to be negative. So 6 over 7. And remember, there's the little, you can write C, A, you can spell out the word cast starting there, right? So this means here, only the cosine is positive. Here, they're all positive. Here, only the sine is positive, and here, only the tangent is positive. That's one little thing you can kind of remember for the main trig functions there. Not the 3 other ones, not the cotangent, secant, cosecant. All right, I hope this helped. If you have any questions, let me know, and have a great week. Thanks.